Welcome to the SwineTime Podcast here at Pipestone. I'm your host, Dr. Spencer Wayne. I'm one of the owners of Pipestone. I'm also one of the staff veterinarians, and I record this podcast. It's one of the few perks of being me. I get to record a podcast with interesting people. So thank you for joining us today. I've got two very interesting guests with a very interesting topic. And my two guests are Scott D., who is our director of research. I'm probably getting that title wrong. It's changed, I bet.
That's close enough.
Okay.
Yeah.
And brilliant researcher. He conducts all of our research here, and we have a deeper understanding of things due to him within our own group at Pipestone. Also with us, Dr. Cesar Corzo. Cesar is the Alan D. Leman Chair at the U of M College of Veterinary Medicine, and according to Scott D., he holds the most important position in swine medicine at the U of M there. And I would say all of us who knew Bob Morrison really appreciate the memory of Bob, and Cesar has inherited the mantle to wear that Bob wore there at the university. So with no further ado, let's get into the topic. And the topic today is PRRS 144. And I'd say PRRS 144 lineage 1C, I'll qualify it a little bit. A rapid response to a national crisis. And two big areas to cover, and we'll jump into it, is one, Scott D. and our group had done some research in some of our barns to understand just how bad the 144 is relative to other viruses, or at least one other virus. And also, does it respect biosecurity? Does it transmit in different ways? And you'll go through that. It's a very interesting piece of research. It was surprising, the results were. And then Cesar is going to comment on what he's hearing from the university level, people that are calling in other veterinary clinics, other systems, what they're finding, what they're seeing, research that he's done, studies that he's done. It'll be kind of an outsider perspective of this same thing, this lineage 1C PRRS 144 virus. So any of the listeners are probably familiar with that. It's the big, terrible new PRRS virus that's kind of swept over us over the last year or more. So I guess we should just start. Scott, do you want to maybe give a little bit of background that I didn't cover now on our finding this and what we've done for research here recently with you? And then I'll turn it over to Cesar to comment on what the industry is saying.
Sure. So as you mentioned, Spencer, we did a project recently. We actually talked about it in our previous podcast as far as we were just getting it started. And the reason we did it was because we needed answers on this virus, because we felt the industry was in chaos. We felt the industry was in a defeatist mode. They were giving up. So they were dealing with this virus. It was apparently the worst case of PRRS they've ever seen. So there's observation one from the field. This is the worst PRRS virus ever. Observation two was no vaccines don't work anymore. And observation three was, independent of biosecurity protocols, this virus gets into farms. Mm-hmm. And so we designed a study to look at those three questions. In a nutshell, we can drill down if you want to, but we found this virus to be no different than the 174 that we've dealt with for the last 6 to 8 years. Actually, the 174 we used was more pathogenic than the 144 lineage 1C that we tested. We found that modified live vaccines, specifically the BI product and the Elanco product, worked very well. And so vaccination was good to do. Pigs performed better when vaccinated. And then we found this virus was, the risk of this virus entering farms was reduced using basically all the steps we've known before. Taking a shower, changing your clothes and your footwear. It didn't live in the pit for excessive periods of time. Disinfectants could neutralize it. A couple of things that were interesting about it, though, pigs did generate aerosols that contained the virus, and filters prevented those aerosols from moving from place to place. That was a neat take home. And the other one we showed is this was pretty easy to spread through the feed. And so this vehicle of feed as a way to move viruses from place to place that we've shown with other viruses also appear to be the case here. So the good news was, though, that the mitigants we tested, the two products that go in the feed, neutralize the virus every time. So that's a real big picture, and we can drill down more, but those are some of our take-homes. It was really not any worse than what we've seen before. Vaccines work fine, and we know the biosecurity protocols to keep it out of farms.
Yeah. So you compared 174 versus the 144. Mm-hmm. Like how bad is it? Actually, it wasn't as bad as the 174.
Yep.
For whatever reason, that's counter to what a lot of people would say in the field. But then you said we assessed all the other biosecurity. in the feed, you said, oh, it appears to live in the feed or spread very well. I'm trying to remember exactly what you said there. We don't have a comparison with another virus. We just know that it'll exist and it will affect pigs. How many hours later, how many?
We basically took feed, we spiked it with the virus, let it sit for 24 hours, and then let the pigs eat it.
Okay.
And these, again, were small studies. There was limited replication. It was just more pilot information. Kind of yes, no. Does the virus live or not? Does it transmit or not? Okay. So you could say that, well, maybe that's a limitation, and clearly it was. But that's really all the time we had, because this was done, as you said, in a rapid fashion.
Right.
Really to get the information ready for the Leman conference, because Cesar and Monsi had given us the opportunity to present it, which we really appreciate that. So,
okay. Yeah. All right. So we don't really know if it's necessarily transmits more than other viruses. We just know that through the feed, at least 24 hours in that feed, will, like other PRRS viruses, it'll be viable enough to infect pigs.
Yeah, we've shown that with 174 So, but those are the only two viruses we've really studied. So it's really limited, but it might be a new twist to this virus that we haven't paid attention to for biosecurity purposes in the past.
Okay. So we recognize this as a big issue. This virus is probably unique. We would have all said that in the room sitting around a table. This virus is extra bad. And then we study it, and it turns out it's the same PRRS that we've been dealing with all along, just with a different number on it. So then we're left with a big question like why. We really don't have a good answer for that, I think, is the way I'm feeling right now. And then we can shift over to a little bit to Cesar and come back to the study if we need to, Scott. But Cesar, you know, at the University of Minnesota, you interact with lots of other veterinary clinics with different systems. You got the health tracking information that gets charted out every month that shows the number of breaks. What's your thoughts on this? You've looked at it. Does it fit with what Scott said? Starting with everybody thinks it's bad. We find it's not as bad. What are you finding?
Yes, and I think that has different portions to, or different answers, right? From our project, we were able to see that last fall, quite a good number of systems started reporting breaks, right? Breaks in a specific region in Minnesota. What caught our attention, and I guess what caught the industry's attention, is that they were clustered in space and time, right? At that time, we didn't know they were clustered until we run some analysis, but it all started in a very dense region. It started spreading. So that kind of generated the alarm, right? And that kind of went together with some farms having high mortality rates, right? In some cases, higher than others. In some cases, there was no mortality that was, to a level that you should get concerned. Maybe some others thought, this is another PRRS break. What's interesting about this one is that it was clustered in time, it was clustered in space, but I think what caught us by surprise is that it was pretty much the same virus. So we said, well, how come this virus is spreading so well in such a short period of time in this region, right? And then we ended up doing some, of course, the sequencing, but we also did some whole genome sequencing, just trying to understand, is it really the same virus? Just because we were just thinking it's the same virus based on OR5. Well, whole genome sequencing confirmed the same thing, is the same virus. So we said, okay, same virus infecting a lot of farms within a region within a short period of time, but then it started infecting some farms that were located in low dense regions, right? So that kind of generated this sensation of, okay, this is really bad. Yes, in some cases it was really bad. Of course, a new virus, when it goes into a new farm that has a little bit of immunity, but if it's different enough, of course it's going to generate a bad outbreak, right? But in some farms it didn't happen like that. So that got a little bit confused with outbreaks of 144 in other regions of the country, right? I want to say towards the eastern part of the country, there was another 144 generating outbreak. So people thought that it was like a nationwide epidemic, and no, it was more centralized in Minnesota and Iowa. So I think those are kind of the reasons why some people thought that this was really bad, which, yes, in some cases it was bad. In other cases, it was kind of like another PRRS break.
Okay. I'm wondering, as you're describing this, everybody got really alarmed. It was geographically centered, so clustered in time, clustered in space. But I almost think back to the past years. Every one of these, how many years has it got? 7 years or 6 or something?
6 to 8 years.
6 to 8 years.
Variant.
Yeah, we have the same conversation every 6 to 8 years. Like, oh, this is really bad, and everybody gets it. And genetically, it's very tight now. This 144 lineage 1C specifically, it maintains its genetic identity. If you look at it, it seems to be conserved, not perfectly, but it'll be within 1% or so of each other. They're all similar, but I think that's been kind of the story every time we have one of these. Is this bad virus rips through. Why it felt different this time is kind of the mystery, because it escaped or evaded biosecurity. It was a chunk of it. The question is it bad or worse than the old viruses? No, it doesn't appear to be when we study it on the pathogenicity. But as far as the replication and the ability to spread, we didn't compare two viruses and how much they would generate for aerosol transmission, or two viruses for length of time living in the feed. Is that some way it could be different? This, besides being pathogenically the same, we're replicated way more. Is that a fair possibility?
Well, when we compared viral loads and the amount of virus in pigs infected with either 174 or 144, we found the pigs that were infected with 174 actually had more virus in their serum, for example, and showed a very stronger behavioral pattern of high respiration rate and low activity compared to the 144. So there were clinical differences as well as virological differences. The 174 being more pathogenic. Again, that's only one strain of 174, and we only compared one strain of 144, but it was lineage 1C, which appears to be, as Cesar was saying, very consistent.
Okay, so really 174, our old virus, made more virus besides the pathogenicity. It correlated with high viral shedding.
Yeah.
Okay, that answered that, but not the way that would have made sense for understanding why this one felt so bad.
I have a little theory with that. I'm interested to hear what Cesar thinks. So we haven't had a real bad PRRS season for, as you're saying, several years, 6 to 8 years since 174 emerged, So people start to forget. People start to get a little lax. It's human nature. But we've also been through COVID, where there was a great deal of economic pressure on producers. And what do producers do during times of economic stress? Potentially reduce vaccine dose. For example, could have been pigs getting vaccinated at lower doses than what's on the label. That may have been one reason why the vaccines didn't appear to be as effective. The other behavior pattern that switched was producers began backhauling complete feed from their mill after they brought a load of soybean meal into that mill. We know how well virus lives in soybean meal. So let's just say, and we studied this in the project, we modeled it. Let's just say we had contaminated bean meal. We had it in our truck, and we brought it to a mill. We emptied the truck. We refilled the truck with complete feed, with no sanitation or no time difference between those events. And we brought that feed back and fed it to pigs. So within a few hours of time, we may have had a chance to contaminate a transport vehicle and then accidentally contaminate the feed. That was a behavior pattern that was going on a lot this summer. And the good news is, if that's the case, it's easy to fix. Just quit doing it.
Yeah.
But we actually studied that in our project and used little model trucks and went through that whole coordinated sequence of events in the day in the life of a pork producer, like we did with the snowball work long ago. So that's something to consider. That may be how the virus got into farms in low dense regions of long distances from, say, in western South Dakota or something, where they're so isolated. Yeah, and so that could be one hypothesis of why this happened.
So this is probably getting further off the course, but it's something I've been thinking about. Soybean meal sits in storage. Is it possible that thing is so uniquely able to support a live virus, that they could absorb it from the air, which is contaminated, generally around it by different air patterns from infected barns, might lay it down in soybean meal? How does the soybean meal get infected, I guess is the question.
I think environmental contamination. Anytime you've got a big epidemic of a new virus, we saw this with PED, you're going to have a lot of infected pigs shedding a lot of virus on dust, on aerosols, on particles coming out of barns, seeding the environment down. And that, to me, we saw that with ASF in China, same thing. That's a great way to all of a sudden contaminate large volumes of feed. So that's one way that we've proven with other viruses that can happen. And we know that this virus lives, or at least 174 lives in soy for over 37 days.
Yeah.
So it's highly protective. So if that soy gets contaminated somehow,
Yeah.
the virus does have a good likelihood of remaining in a viable infectious state. So I'm curious what Cesar thinks of that. But from the microbiology point of view, I think that's got a lot of credibility. That's hypotheses that should be tested further, but maybe some new ideas to think about.
Yeah, you could explain how it gets out remote. You're injecting it across the country by very specific missiles of infected product. I don't know. That's a few studies away from having any knowledge of that it could actually happen that way. But I'm thinking of how does soybean meal get that contaminated if that is the case? I'm going off on a rabbit trail there. Cesar, what's your thoughts on that? How did this thing actually spread around? We didn't find it in research, but do you have any suspicion of how it actually got spread around if it was spreading more? And the charting would show that it did. Maybe not dramatically, but it would pick up that there was more PRRS at different times of the year.
Yes, and I agree with Scott. One of our charts show that. So we normally see that the epidemic starts in October, November, right? And roughly between 20 to 30% of the breeding herds in the U.S. break in a given year, right? Last year wasn't different. We did see an uptick in April, May, and that was due to 144. However, we did see in one of our other charts, the one that we call the EWMA, we just saw that we kind of had like two waves, right, to the epidemic. The typical one starting in the fall, ending in the spring. But for some reason, with this virus, we saw another wave starting late spring and a little bit into the summer, right? When we add on the amount of sows that became infected, it's kind of an important number. I want to say that it's over 250,000 sows, maybe more because we don't have all the sows of the industry in our project. So I think that makes us think, okay, how in the world was this virus so effective, right? And this takes me back to my first years in my PhD. Scott was there. We had all these discussions, and Scott, you were one of the ones who kept insisting to our students is this always need to think on fitness of the pathogen, right? At that time, I was kind of transitioning between PRRS and SIV in my thesis, and it was kind of the same thing. There's some pathogens that are really good at transmitting. Not necessarily they're going to kill the other hosts, but they're just really good at transmitting. With this one, I think that there's some data from practitioners out there describing that the CT values of their samples were pretty low. And I remember at some point, this reminds me of Dr. Matt Alderson and I had a contest in that we wanted to see who would get the lowest CT from a SIV standpoint because we were both collecting samples. And yeah, we got down to the low teens, actually to a one digit, and we said, well, how come these animals are generating so much virus? Anyway, so I think that may have happened with this virus too. Maybe it was just good at generating good amounts of virus, putting that out into the environment, and then from then on, just like Scott says, the probability of cross-contaminating it just increases by the minute, right? When we looked at our data, and this is work from Mariana Kikuchi from our group, she presented this at the Leman conference. She conducted a case control study, just trying to answer this same question, right? Trying to say, why is there any way we can find how different this virus is at transmission rate? So she compared outbreaks with lineage 1C 144 and other PRRS outbreaks in the same period of time. And she looked at farm type, she looked at manure storage, she looked at whether the feed came from specific feed mills, whether they had feed mitigants, whether they were filtering, whether they were vaccinated, both breeding and growing pig farms. And we couldn't find a single factor that said, hey, this is different between L1C and the other viruses. So it kind of left us a little bit frustrated, like PRRS does pretty much all the time. It didn't give us like a good sense of this is the only route. What we do know is that some practitioners have been reviewing their biosecurity protocols, and in some cases they have found some opportunities, right? So I think it goes back to that. Yep, new viruses happens every 4 or 5 years, like Scott said. Maybe a lot of viruses got generated. contaminated a lot of things. Maybe we helped the virus move, and that's why it was a little bit unique, right? Together with cluster in time and space being the same virus as well.
Yeah, what's kind of interesting to me is that Scott's work would show it didn't replicate more, but you said, well, maybe we just missed it for whatever reason that trial. Which, well, if we did it again, will we find it? Because I've seen the lowest CT or the highest amount of virus for PRRS with this virus. So it's striking to me that it'll be low teens CT value in pigs when you believe, like, man, it seems like a lot of virus. We didn't find that on our trial. I don't think your study, Cesar, necessarily studied that. It couldn't have, because it didn't have the information available, probably.
We didn't look at it. Yeah, we didn't look at it. Yeah.
We looked at CTs. Obviously, they're the inverse of the RNA copies,
Right.
and it was the same thing. I mean, they're low. These pigs had strong or low CT values, no doubt.
144 was lower than 174?
No, there was no difference.
No difference.
When you did it statistically, when you looked at the means and the ranges, there was no difference.
Yeah.
We did look at CTs, but basically that's the same thing as the RNA copies, just flipped upside down. So
Okay.
I wasn't surprised we didn't find anything different.
Okay.
Mm.
Well, okay, for the sake of moving the discussion along in time, we just sat here and a bunch of smart guys thinking we know stuff. And then Scott presents this at the Leman conference. You just shared what you're finding, Cesar, on like essentially like there's no there, or there's no obvious smoking gun for something different, or why it seemed as bad. You interact with a lot of folks. What have you heard back from the industry, Cesar, on this? When you've talked to people and they listen to Scott's talk, they say, well, yeah, but he missed this, or this is different. What's the industry saying? That somehow, did we miss something? Is it really, we've actually discovered the truth, it isn't worse? Or what are you hearing back from people?
And of course, I get to talk to a subset of the industry, right? Just because of the nature of our project. And what I hear is that the breaks from fall 2020 were a little bit worse than the breaks, I want to say spring, summer 2021. Now, I can give you numbers like in an average of, in a regular 3,000 sow farm, we've heard that some farms have had in a couple of weeks 200 abortions, 300 abortions, and who knows, 200 sow deaths, So those are kind of important numbers from production standpoint. But then within the same window of time, herds that break with the same virus haven't had the same impact. So that's kind of when you start thinking, why is it so different if it's the same virus? Well, there's many other factors involved, right? Co-infections, management, environmental, that we're not accounting for. So that has changed as time has gone gone by. So I think that it seems that, and I don't know if this is true or not, this is just thinking out loud, is it attenuating, yes or no? We can't compare farm and farm just because there's so many different variables in there. So I feel like it's kind of getting to a point where we say, okay, maybe we're out of the worst part of the outbreak. Yes, we see 2 waves on the graphs. That second wave is kind of having a decreasing trend. It's kind of a scary 2 waves when we look at the data. And then we would say, are we going to have a 3rd wave? Well, we don't know if that's going to happen in the fall. What I have been hearing and seeing is that a lot of the systems, like I said earlier, they have been going back to, hey, let's revisit all these biosecurity protocols. We think we're doing this, but are we actually doing them? Are we actually implementing them appropriately? And in some cases, there's been some surprises, Spencer, in the sense that, there's a famous saying that you know very well, I trust, but I better double check that that's happening, right? So I think that's where we are today, 1. And 2, there's other systems wondering, is this related to the shortage in personnel, that maybe we left some of those gaps in the biosecurity program? Maybe not. Some people have those theories, and that's good, because they're just going back to the basics and making sure that the program, the biosecurity program, is actually working properly. So I think that's good. It doesn't hurt to go back to the basics every now and then.
Yeah. So the next thing is, well, what does the industry do next? What's the next step? You've already just laid one out, which is just go back to the basics. Go back to making sure people are following biosecurity. If we got lax, like, is everybody showering in? Is everybody being careful with materials entering the unit? All those things. And I know for us, just to share an experience with us, we had feed mitigant in a lot of the diets, and as these things started occurring, we put them back in. We took that a lot more seriously. That may be hit or miss throughout the industry if they're using feed mitigants. But what else, besides good biosecurity, where does the industry go from here? Either of you, I guess I put the question out to.
Oh, I guess my 2 cents to the industry is don't give up. Kind of what Cesar is saying. I mean, this is a new PRRS virus. It's a very virulent PRRS virus, but it's nothing different than we've dealt with before. It's a new strain of PRRS. There's never going to be, pigs are going to be more naive than, once they've seen it, it's going to be a whole nother situation. But follow the rules. Don't take shortcuts. Consider a feed mitigation if you have faith in that route of transmission. Hopefully you're filtered. But we know how to deal with this virus. This is nothing we can't handle. So we simply cannot give up. We just have to follow the rules.
Yeah. Okay. So go back to the basics. Embrace the filtration. If you got it in a real way that's going to be effective, make sure you monitor your system. The feed mitigants. Cesar, anything else? Things you would say that the industry is going forward with, the people you're talking to?
I agree with Scott. I think PED gave us a good lesson. PRRS continues to give us a good lesson. Go back to the basics. There's plenty of technologies out there from a biosecurity standpoint that are worth looking at it, are worth giving them a try. Because at the end of the day, the more we bridge that gap of, how would you call that? Uncertainty when it comes to biosecurity, the better. We just need to continue to bridge that gap because pathogens, like you just said it, they will not respect anything, especially when we are running really, really hard every day trying to get all these systems to work well. There's a lot of opportunities for mistakes or, oversight of little things, and those are the ones that come back and bite us, right? So I think it's just like Scott says, do not give up. Just keep working. It'll happen. Very likely it'll happen again, but the better we are at compliance and the better we are at using all these new technologies, I think we're going to decrease the probability of infection. Just like we saw here, we have farms 1 mile, 2 miles away from positive cases that have survived the 2 waves of 144. Why? We don't know yet. Maybe it's just better compliance. Maybe it's filtration plus mitigants or the whole package, So that's another learning from this place.
Yeah, the whole package, that's a good point, Cesar. We can't forget about using vaccines correctly. Disinfectants we know are effective. We got to use, I know I'm talking feed and filters, that might be a little Star Wars for a lot of people. We got to go back to these other real, as you're saying, real foundational aspects for virus control, such as sanitation and vaccination. So that should be a real big focus of this as well.
Okay. We could end there, but I want one more question, and that is, we did our study. Cesar, you got information from your study, from industry feedback. What do we study next on this, or is this enough? We got it. Are we done studying this particular virus, I guess? Any comments on that, or are we beyond it now, or let's look at the next thing, but this is done?
Well, my point of view, our study was small, and it'd be nice to repeat it, it'd be nice to expand it, look at just more replications, more statistical power. I don't think we need that right now. I think we have enough to move forward, but I imagine in the next year or so, there'll be more of those types of studies just to give us more quantification of some of these protocols, which are better than others. The other day, we just looked at yes, no, alive, dead, very pilots. So that's where I think it might go.
Cesar?
Yeah, I agree with Scott. Perhaps the one thing that we may be doing a little bit in the next few months, maybe years, it's a little bit of replication, just making sure that nobody missed it. Looking at maybe is it different at surviving outside the host? Are there any other transmission routes that we're missing? Which I mean, it's hard to believe, but little by little, we kind of every now and then we kind of realize, oh, there's going to be another potential route of transmission, right? Minimum infectious doses, maybe that could be another option as well. Things like that will help us understand a little bit more how this virus behaves, because we continue to get scared by this pathogen every now and then. So, and I think the last one is and I like Scott's comment. Let's not give up, and let's try to continue to figure out and then do better outbreak investigations, because somehow it's finding its way in, and it's better to know whether it's human error or it's actually something that we're helping the virus reach its objective, right?
All right, that probably is a good spot to end. I appreciate you guys both being available today to talk about this. I know this topic has been on the front of a lot of people's minds that are involved in pig production and trying to keep free of this virus or dealing with this virus. So appreciate you both being here.
So talk to your vet, get the information, and don't give up.
Yeah.
Just don't give up. We know how to do it. We know how to manage this thing.
That would be the worst thing for after this 144 is that people say, well, biosecurity doesn't work anymore.
Yeah,
and they just
that's
gave up,
bad.
or this doesn't work. And
That's not going to help.
yeah.
That's why we did the study. We were worried about that attitude in the industry permeating and taking over people's minds. So credit to Joel Niram, our CVO, who jumped up and said, we got to do a project. So we did.
Yeah. All right. Thank you both for being here. Appreciate it. Also, I appreciate our listeners to the SwineTime Podcast. Join us next time for our next guest. Thank you.
SwineTime Podcast was created for the pork industry and individual pork producers around the country. Hosted by Dr. Spencer Wayne with the Pipestone Veterinary Services, the podcast contains pork industry news, advancements in animal care, and how to enhance your productivity. Monthly podcasts are available on Spotify, Google Music, iTunes, Anchor, and on www.pipestone.com.